guys. Well, we're going to go ahead and start on another project here, and this project I've got on the list here is the motorcycle jackshaft hub. Now, this is the item here that I've got to manufacture. The motorcycle guys have always called this a jackshaft, but I think it's not the actual shaft, it's the hub assembly, the sprocket assembly. You got a shaft that goes through there. And in case you're wondering what this is used for on a motorcycle, for the guys that don't know, on a swing arm that uses the wide tires, the wider than stock tires, that's a popular mod that guys were doing, was putting the big 300 millimeter wide tires on long extended swing arms. Well, you got to offset the chain to reach back to the tire. So they have this kind of system here built into the swing arm. So you come off your transmission to this side, or I don't know which one, but it comes off to one side and then it's offset, and then you have another chain that goes from here to the back tire. So these things are commonly get wore out, and they always find that it's very hard to replace these things. I think these manufacturers that build these swing arms, and we had this whole big boom back in the 2000s with this whole chopper thing. I think a lot of it's kind of settled down now, but you had guys on every corner building choppers and motorcycle parts and things like that. So there's probably still a lot of this stuff out there, and I've already dealt with it for years, that guys cannot buy replacement parts for these things. So the next best thing is to go to a local machine shop and see if you can have it built. So that's what I'm going to do. I'm going to build one of these things. You can see they're pretty well worn out. And I have no idea if they're racing, drag racing, or whatever. So that's what we got to do. I got a piece of steel right here. This is a drop, or it's actually a scrap piece of material from work. It was a hydraulic rod, and this was a 70 millimeter rod. So basically 2 3/4 on my end. And I just cut a piece out. That's going to be the center right there. And what they usually do is they bring me sprockets, like factory style sprockets, and they are a complete nightmare to try to machine. You have a small spline center, and you have to anneal them because they're hard as a rock. So you have to anneal them to be able to machine them, and you got to be able to hold the sprockets, so they're usually an aggravation, and they're not a very fun job to do. I went a different route this time. I actually got with Martin Sprocket and was able to order 2 of the sprockets that I needed for this application right here. They don't really, these kind of sprockets usually don't cost that much money, and I went ahead and had them bore the center to 2 3/8. That's what I decided I wanted for it to fit here, is 2 3/8. And they also hardened it for me. They hardened the teeth, so it's still a little soft here in the center, and you have a flame hardened sprocket tooth on this. So that'll make my job a little easier right there. So we can take a piece of stock. I didn't have any tubing the right size, so we're just going to start with a solid piece. We'll drill it and bore it, and we'll be able to machine one side for a sprocket to slip on there. It'll have a shoulder. All right, then we'll flip it around and we'll finish that side. I'm going to rough bore the ID for the bearings, and what I'm going to do, I'm going to put an 1.5 inch center hole through this. And what I've decided to do is, the reason I'm going to do that is after I weld these sprockets on there with that 1.5 inch bore, I'll be able to set it back up with this expanding mandrel here. I'll put it on that expanding mandrel, and then I'll be able to finish the bore for the bearings. You have a ball bearing, a standard ball bearing that goes on each side there. This is a 6304. So you got one that presses in each side, and I don't want to finish it and then weld it because that's probably going to draw. So I want to weld it on there and then come back, set this up, and finish it the size, okay? And so that's the plan of attack. Also, I'm going to make a new sleeve. This is what was in there. I mean, That's what they put. You got a spacer that spaces in between the bearing races right there. So I'm going to make a new one of these. I'm not going to use that right there. So that's what we're going to do. All right, so enough talking. We're going to use the 4-jaw chuck over on the Victor here. So let's go get this chucked up and get to work. All right, we've got the chuck preset for the 2 3/4 or 70 mil OD. And what we'll do, we're not going to slide it way up in there. We'll machine this side and then we'll flip it around and turn the other. I'm going to turn this OD down to 2 5/8. All right. Okay. I say it's close enough, but I want to make sure that my jaws are all snug, so I'm going to go back around it again and check it. Probably going to move it a little bit. Yep. There we go. Okay. Let's try that one. Oh, we're going to use it in the Victor this time. That's all right. That's all I wanted. Just a little spot to start the drill there. Then once you get way up in there, the drill's getting so hot, you try to apply it. I mean, it's not, you're cooling it down a little bit. You see it just falling off. So I'm taking it and just kind of sticking a little at the edge of the hole so that the drill pushes it in there. That was the end. I'm going to go ahead and bust the center out with this 1 7/16 drill bit, and I just touched the end up. It had a couple of chips in it I didn't like, so I'm going to keep trying the anchor loop here. And I wanted to tell you one of the benefits of this. I'm not trying to say which one's better. I like cutting oil and I like this stuff too. One of the benefits of using this in a shop like mine, I've got an air conditioner running and I don't have like good ventilation right now. this doesn't smoke up like cutting oil, so that's a good benefit of it, okay? It takes longer to apply it than cutting oil, you know, using the eagles, and it's harder to get up in the hole. Nice even chips coming up out of there. All right, so let's see. We'll cool that down a little there. I'll go ahead and try to get a little bit in the hole. And my hopes is that as it's drilling, it's trying to disperse this. Try that new carbide boring bar that Eric Skinner gave me. All right, just getting everything set up, and you know we got about 50 thousandths to come out. We're just going to take that to 1.5 inches, okay? Looks like it did pretty good. All right, we'll just measure this and I'll take one more cut through there. 27, 28. Double check it. Looks like we got 28 to come out of it. And I got it nice and cooled down too. Got that fan up there by the air conditioner, and it helps to turn it down here on the lathe when you want to cool something off. Okay, I got 28 to go. I'll do this. I'm going to put just a little touch of that in there. I got to get my pliers down. It's leaving a nice finish in there and looks good, nice and smooth. Bam, Right on it, 1.5 inches. Okay. All right, I'm going to go ahead and get the counterbore roughed in for the bearing here. We're going to be going 15 millimeter deep. I've backed off about 10 thousandths so that whenever I finish it, I can finish out the face in there, okay? But I want to go ahead and get most of it roughed out. I'm probably going to leave a good 1/16 of an inch, you know, around 60 or 75 thousandths to finish it. And another thing, I think I've showed you guys this before. This is one of my charts right here. You know, 6306. What do we got here? 6304. Okay. If you come across, there's your housing diameter. You know, low and high right there. So 2" 47 2/10 is your minimum, and 2" 47 9/10 is your maximum whenever we go to finish it. So I thought I'd share you. These are really helpful to have whenever you're doing bearing fits. Okay, one more thing. I'm going to try a new insert. This is one of the inserts that Mike Suppose sent me recently. It is an ISCAR CCMT. It's an IC807. So I want to give it a shot, see if it does any different than the one that Eric had on here. I'm going to start with a 50 thou, and then I might bump it up to 100, see what it does. All right, pretty good so far. Now let's try 100 thousandths and see what it does. Looks like it's handling it fine. Slinging some chips. I still forgot to go over there and get my pliers. Another 100. Mike, that insert's doing good, man. That's the first time I've ever used one. All right, I'll be right back. Try a little bit of the lube and see what it does. This should be our last cut. It'd be around 1" 900. So, but I want to back off some on what I was taking. So I think we're going to go. Let's just go 80 thousandths. That should give me plenty of meat to machine out of there. Okay. Just get rid of that sharp edge there. All right, we'll go ahead and get the OD finished on, well, we're going to turn it down. I want the main part of it out here, 2 5/8, and then we're going to turn it down here to 2 3/8. All let's finish it off. We need 63 thousandths. All right, we'll go ahead and turn back our area that our sprocket's going to slip on. So we're going to move back. The distance is 650 thousandths. That's also equal to 16.5 millimeter. Okay, got to take it down 1/4 inch. Dial in 1/8 of an inch here. I've already got my zero set. Alright, I'm going to go to 225, back off there, and then we'll take some light cuts. Every now and then you get a chip that sticks to the end of the indicator there. All right, I had to go in here and reset everything. I thought I messed up, but what it was is that first pass, I wasn't paying attention. There was a chip here on the end of the indicator, and I stopped my zero too soon, but it looked like I had already gone into the shoulder on the second cut, and I wasn't on my zero yet. So I had to redo it just to make sure. So we're good now. We got 20 thousandths to come off, so we're gonna speed it up, take a light cut, and finish it out. They've got the sprockets bored to like 2-inch 377, 378 with calipers, so I want to try to make sure that we maintain a close fit. So 10, 15. See that last little bit there, that was, I left 5 thousandths so that I could clean the face up. It's gonna be pretty snug right there, I think. Should be able to press that on. Let me mic it. Yeah, 76. Where's 376? Let's see what these digitals say. 377. All right, so that should go on there. I've got a very sharp corner and I'm not getting it straight, so it's not really hot. It's a little warm, so yeah, I'm thinking I'm gonna leave that right there, and we might be able to just tap that right on down on there. All right, we got it flipped around. I haven't indicated it yet, and you can see that by the run out, but I had to get it set so that I can get in here, you know, with some calipers or something like that and measure this end length whenever I do my facing. So should be pretty good right there. We'll check it in 2 spots here to make sure that we're running straight. Okay. Get down to those last few and just start tightening it up. All right, let's check it. What we'll do is we'll move it out here. Got a little bit, so we're kinked just a little bit. Not bad right there. Then we'll come back, check it here again. And back here again. Come on, man. You got it pretty tight. Yeah, I moved it too far. I think we're going to live with that. There we go. I'm probably going to have to check it here again. It's a 1/2 thousandths. I think we're gonna run it. So our end-to-end length from face to face is going to be 2.900. That's what the old one is, so I'm just copying that. I got about 1/8 of an inch that I still need to face off this. Okay, 40 thousandths. There it is. All right, that put me 376. That's what I was shooting for, because these sprockets are, the caliper's 377. So yeah, it'll go on there one way or the other. Okay, we're on our last counter bore for the bearing. Just going to go ahead and get this roughed out, all right? I like that little boring bar, man. That thing is smooth. chips are a little more stringy than I want, but I'm not running a very fast feed. Yeah, the marks in there, that's from them chips getting packed in behind the, in between the insert and the wall there. So, all right, let's just chamfer it real quick. I got this other bar that had this tool in it, so I just used it. We'll slow it down some. Okay, all right, I just need to do a little bit of filing on the edges, and I'm gonna hit that with some emery and we'll be good to go. Let's see if we can get these sprockets started. Let's go ahead and go press it on there. Pretty good fit. All right, one more. Okay, I'll go get the other one started and we'll come over and press it on there. I got it pretty close. I'll have to do a little fine tuning to get it timed closer than I got it anyway. We should be able to, here we go, take it and just kind of set it, and I'll be able to manipulate the sprocket a little bit. I'll take and with one of my soft punches and just kind of tap it a little bit until I get this, it's almost there, it's just a little bit, and bump this sprocket around a little bit and then get it sitting completely flat. All right, I got it pretty well timed right there. All right, so next step would be welding, and I think we're going to use the rotary welding table this time. And I never did finish my my little mounting system that I wanted to do over here on the table, but I might go ahead and modify a T-nut or something so that I can bolt this in and stick it in here like that in the vise, clamp it, and then maybe be able to move this around a little bit. So we'll see. So let's get started on it. All right, so what I'm doing is just modifying one of those big T-nuts to fit the T-slot. I'm just doing one right now because I'm in a hurry. I already got one side milled. And I'm just using a little bit of the anchor lube right here. Quick and dirty. And then I'm going to drill and tap a hole in the top, and I haven't decided what bolt size, but it's probably going to be 3/8. Well, I got the little vise finished up and modified that T-nut so that I can mount it on there. And this will work. It looks pretty good, but I'm a little unhappy with the size of the vise and the rigidity in it. It's a little more loose than what I thought it was going to be, but it'll work. It'll work for now, and maybe one day I can pick up a lot nicer vise to go on here, a bigger vise. Who knows? We'll run into something. But so I've got the like I said, I got this T-nut modified. I've got it to where it's basically, you know, I've got it loose where I can just pivot like that. So that'll make it kind of easy there. I can get some of this welded and then swing it on around and do some more, and then also loosen it up and kind of move it around a little bit if I want to do it that way also. Okay, so that's the setup. And also I was going to show you real quick the expanding mandrel right here. This is what we're going to use to set it back up and finish these bores for the bearings. Well, there it is. That worked out perfect. So we'll chuck this in the forge jaw and indicate it. Come in there and just skin that ID for the bearing. Alright, so I got to get this thing set up, get the TIG set up, and we'll start laying some rod down, alright?